Now, continuing our focus on innovation, the next session will discuss innovation for sustainable desalination and water reuse. Please join me to welcome the speaker of this session, Mr. Greg Welch, Director of Brine Strategy, ENOWA.
Hello, welcome. Thank you so much for that. Interesting panel we just had. I think there was a few discussion items there which I might touch on here with regards to developing sustainability around an overall strategy that the kingdom is looking at right now. So yeah, very interesting stuff. As you know, I'm Greg Welch, Director of Brine Strategy. Actually, my full title is Director of Business Development. I'm going to go through this presentation this afternoon just to talk about some trends in desalination that we are seeing. This presentation was also put together by my colleague Nikolai Vochkov, who is the head of the Water Innovation Center for NEOM also. So I'm going to give you a little bit of a background about NEOM to begin with. I believe many of you probably already know what NEOM is, what it stands for, what we're trying to achieve. But just in case, we'll go through this a little bit. NEOM is a region in the northwest of Saudi Arabia. It's one of the underpin pillar projects of Vision 2030. We are looking to develop basically a cognitive city that is based on sustainability and new ideas in the northwest of Saudi Arabia. It's an area around the size of Belgium, and we're basically dealing with a blank sheet of paper within NEOM, which gives us so many opportunities to actually develop it into the way that the vision is aligned to. So as you can see, it's an opportunity to redefine how we approach things in life, how we approach livability, and a way to redefine how we approach business, and also conservation. Just to give a flavor of some of the current developments within NEOM, I think many of you, again, these might not be a secret to anybody. The ones that we have announced so far in terms of regions that are currently being developed in NEOM. We have Trojena, which is the mountain development, which will be host to the 2029 Asian Winter Games. Sindala, which is a luxury island that is being developed right now off of the coast of NEOM, which is going to be opened up, expected to be open next year. The Line, which I'm sure everybody has heard of, which is our approach to how people can live in a more linear fashion rather than the typical cities that you see with urban sprawl. Oxagon, which is our industrial area, and a nature reserve as well. Just so there's no confusion about what's the difference between ENOWA and NEOM. ENOWA is the subsidiary company of NEOM. It's 100% owned by NEOM, and it has been set up to essentially develop out the energy, the water, and the hydrogen requirements for NEOM itself. So I work for the water sector within NEOM, and both the water sector and the energy sector are looking to develop out the water and energy needs for this new region. Just so people are aware, the energy within NEOM will be 100% renewable energy, so that will be across all of the region. As I mentioned, the previous panel talked a lot about how the strategy within Saudi Arabia is going to work towards some essential sustainability outcomes, at least sustainability in terms of water supply. We have a vision, we have a strategy within NEOM's water sector that was put together a few years ago, which essentially goes along the lines of circularity and resilience and the ability that we can maximize on those outcomes. You can see on the right-hand side of the screen here the UN SDGs that we are aligned to within NEOM, because there's several of those. So what we're trying to do is essentially build out a system from the ground up that is aligned with those SDGs and is very environmental. It takes into account all of the aspects of circularity and provides a safe and reliable water system. So if we jump into desalination and what we think we will see in the next 5 years, if we look at desalination and the trends that we've seen over the last, say, 20 years, we know there has been a lot of innovation, there's been a lot of movement. The cost of actually desalinating water has gone down quite dramatically. So what we think we will see in the coming years is focused primarily on improvements in membrane productivity. So we can talk about things like nanostructured membranes. In other words, the ability that we can specifically design a membrane so that it gives us a certain amount of selectivity and is actually just fit for the actual purpose that we want it to be. Things like biomembranes, which are more along the lines of mimicking the types of membranes we have inside the human body. And again, I think the third bullet point is a key one in terms of the longevity of the membranes themselves. It's one of the biggest pieces of your OpEx within your desalination facility. So if we can increase that longevity, then we're going to go a long way to improving the overall cost element of our desalination. And then membrane cleaning, again, that's another one. If we can improve the membrane cleaning system, again, that's something that will definitely improve. In the bottom, you can see we're talking about brine mining and green chemicals, and that's something that I've been spending the last few years on in NEOM. And you know, traditionally, there has been obviously a lot of work that's been done on this from an innovative perspective, a lot of selective brine mining, especially in the industrial sector. But from a complete water supply perspective at NEOM, we are looking at doing quite a large extraction of these valuable chemicals and minerals and actually building that into our overall model and our overall business case. So this is something that's really quite exciting. I mentioned the membranes, and if you look at the fabric of the membrane itself, again, it's this type of specific design that we can now do at a very minute level that is going to give us that ability that we can provide membranes that are much more selective than what we have seen in the past. We know that seawater is mostly fresh water, but it's that small element, that 3 to 4% of salt that we're trying to take out. And that's what really causes all of the processes that we put into this when we do seawater desalination. But again, to be more sustainable and to develop this in a much more robust way, we need to really look at how best we can actually take that salt or that brine, and rather than send it back to the sea, how can we extract the best value that we can from that brine? We have magnesium, we have potassium, we have calcium, we have all these wonderful chemicals and minerals that are there, that many of which are typically mined in traditional mining processes, which are not very good for the environment. They create a lot of CO2, and we have the ability that we can exchange that traditional mining method with this. What we are doing at NEOM as well is essentially our approach to desalination is to look at it as a fully integrated system. So in other words, we don't just want to build a desalination plant and to say, okay, what do we do with the brine now? We want to actually make that desalination plant the first stage of our brine processing facility. So one of the things that we're doing, and we know others have done this as well, is to look at how can we be most selective in actually getting that brine out and giving us a brine that is much more easier to valorize downstream. So As you can see here, if we invoke nanofiltration, we can pull out the polyvalent brines, the magnesium and the calcium-rich brines, and then from the RO membranes, the monovalent brines are things like our sodium chloride, our potassium, our rubidium, and our lithium. So this is a very key point if we want to put in a very robust brine mining system. So, as I said, the minerals that we can get out of the ocean, we can use those for fertilizers to grow food. We can use those, we can take the salt and we can utilize that in chlor-alkali systems, and we can make PVC, we can make plastics. We can take the gypsum and we can utilize that in building material, in gypsum wallboard. And the salt also we can take and we can use that in the pharmaceutical industry. So if we have a look at, if I go to this next slide here, if we have a look at the approach that NEOM is actually taking here, we've actually divided this into two stages. In the first stage, what we want to do is we want to be able to extract those, what we call those base products, which are really the commodity products that we get out of the brine. So it's the elemental pieces, it's the sodium chloride, the magnesium chloride, and such. And once we can extract those, then we have the opportunity that we can take that to the next level. We can actually make high-value products. We can take the salt, we can run it in through chlor-alkali, we can make PVC. We can create soda ash from our brine, and we can take our soda ash and we can make glass. We can take the gypsum and we can create gypsum wallboard. We can take the magnesium chloride and process it into magnesium or magnesium alloy. Or potentially we can also take magnesium refractory. So there's endless numbers of possibilities here. What's very key for us in NEOM is that as we look to develop this city on a very sustainable manner, we want to, as best as we can, replace the types of products that we would normally have to bring in from outside, which may have a much higher carbon footprint and perhaps were not created very sustainably, with what we can take out of the sea, which in many cases people were previously thinking of as a byproduct, as a waste. So this for us tells a very good story. If again we sort of put on our glasses and look into the future, what we think about in the next 20 years, we think this is going to accelerate in terms of what we're going to see in terms of cost and power reduction. We are going to see more fresh water produced from the same saline sources. In other words, a much higher recovery in our desalination systems. We're going to see a reduced energy footprint, which we can get from various means. And we're going to see AI. There was a question just, I think, before the end of the last panel about AI. And although I think our panelists were correct, is that we probably don't see a lot of that invoked in a lot of our facilities now. That is definitely the future, and that is definitely where you are going to see more emphasis on. In terms of energy, we can consider that we will get higher efficiencies across some of the key elements within our system. So our high pressure pumps are going to start becoming more efficient because of more technology and more development that goes into this. Our energy recovery devices are going to become more efficient. And we're probably going to eliminate some of the elements that we have in there now, which we just don't need anymore. So in other words, some of the pumps that we have in terms of recirculation pumps, we will no longer need. So it'll be kind of like an optimization of that whole process based on increased technology around energy recovery. We mentioned AI. This is something that a lot of people are looking at right now. A lot of utilities are looking at. A lot of these existing practices that you see there. Many people aren't even doing those these days anyway. I don't think you see anybody that's doing a lot of 2D drawings right now. A lot of it's coming into BIM. It's coming into digitization and so forth of these assets. So this is where we'll start to see that these digital platforms will become more and more prevalent, and not just from a design perspective as we design out our facilities, but also from an operational perspective. We'll start seeing things like remote operations, and we'll see things like being able to use digital platforms to actually provide our digital O&M manuals and virtual learning programs at the same time. This is much the same from the previous slide. Again, just an emphasis on that these digital platforms and these digital twins for new assets and existing assets is going to really start to take a forefront as we develop these into the next generation. We can also utilize virtual reality. So we no longer would we actually have to have our operators being trained right in those facilities. They could do this training in a remote area, and through the use of virtual reality, we can actually get them to visualize and see exactly what those elements are within the facility that they need to be trained on. Remote monitoring as well, and remote expert assistance will also start coming in, so no longer needing to keep such experts actually in your facility. You could dial them in whenever they are needed, and they'd be able to be fully integrated into your operations to provide that element of expertise that you require. Through fiber optics, through 5G, through other various connection means, we want to be able to connect up all of these systems together, and that's what we will see. A lot of that is being done now, but we will see more efficient ways of being able to do that in the future. This is something that I find really quite exciting, is if you think in a plant that you normally would need to keep quite large inventories of spare parts, if you had the ability that you could actually 3D print those spare parts, then you can see the opportunity that it creates in terms of smaller inventories that you would need to keep at site, and probably from a cost perspective as well, you would not need to pre-invest in components that need to just basically sit there on the shelf and gather dust. So I think this is something that we are going to see, and there'll be more and more advances as 3D printing gets more and more advanced, and the elements that we can actually print become more complicated. That this will really become something that's going to be quite exciting in the industry. I think as well, I think what we will start to see also is how best we can try to combine both our efforts along desalination and water reuse. And there's a couple of elements here that come to mind. Part of it is looking at how we can take a very high salinity water from a brine, and we can run that across a lower salinity water from a reuse type water. In this case, I think it's coming from an MBR, or maybe that's on the next slide. And using that difference in that salinity gradient, we can actually harness that energy across an osmotic system. We can also take that reuse water, and we could actually dilute our seawater with it, which would mean that our membranes wouldn't have to work that hard, or as hard as they were designed for, giving us better performance. Now, that leads into a few other debates about direct reuse of direct potable reuse. But again, from a technology perspective, this is something that could be looked at in the future as well. This is just an example from illustrating what I just showed on the previous slide, where we look at this technology, pressure retarded osmosis, and whereby we actually combine the brine coming from a desalination RO plant and the reuse water coming from an MBR facility. We run it across a membrane, and we actually recover, because of the gradient there, we recover the energy. So again, these are all things that we see are going to be developed further and further in the future. Some of the technologies with high disruption potential, again, these are ones that are maybe not used that much right now, but we see again will be used more in the future. Forward osmosis, membrane distillation, both of which are going to provide much higher either energy use or lower energy use or higher recovery rates. Maybe just in the sake of time, I'll jump down to the bottom one here, which is membrane brine crystallization. And this is something that, in fact, within NEOM, our research innovation center is looking at piloting, because if we can replace traditional thermal evaporators, or thermal crystallizers, I should say, with membranes, we have saved a lot of energy, and it also gives us the opportunity that we can be more selective of what exactly what we are trying to crystallize at the same time. So again, the forecast for the future, we see the cost of water, the construction cost, and the power use. All of these are elements that within the next 20 years we see dropping quite dramatically. At the same time, we will see that the actual membrane productivity, the membrane useful life, and the plant recovery will go in the opposite direction, and those will get much better. So these are predictions, but given the amount of effort that is going into R&D and innovation that we see across the globe right now, we think these are probably achievable. So I'm running out of time, so just in concluding, we will continue to see the ocean as a very reliable source of water in the near and future. Seawater desalination is going to continue to be very economical and cost competitive in the future. And we see that in 5 years, we could potentially see a 20% reduction in the cost of water. And if we include that additional investment over the next 20 years, we could potentially see our cost of desalinated recycled water drop by 80%. So thank you. Do we have time for questions? We have time for one question.
Thank you for your presentation. Just a quick question. It's great to recover minerals from brine and reduce the discharge to the water, to the seawater. In terms of energy and environmental impact of the process of extracting these elements, I mean, it's great to have mining from the sea, but is it possible in terms of energy and environmental impact? Thank you.
It's a very good question, and I think, as I said, we've spent at NEOM and in ENOWA, we spent an awful lot of time and energy in the last few years looking at this. Brine mining, to be successful, relies on getting that energy mix and getting the energy right. You need to have a low-cost source of energy, because a lot of these technologies that you may look at putting in downstream, essentially what you're looking at doing is you're looking at a lot of these are just extracting minerals from water, because the brine that comes out of your desalination facility may be at 100,000 milligrams per liter or whatever, but you've got to get that up to either a fully saturated brine before you can crystallize it. And there's a lot of energy that's involved there. But you're right, if your energy mix is going to rely on a lot of, say, fossil fuel type energy, then that is not necessarily going to push you in the right sustainable direction, because you're going to be creating a lot of CO2 just to actually create something there. So, I mean, what we're trying to do at NEOM is 100% renewable energy across the board. So it's a bit challenging, because we have to actually get that flexibility right across, because with renewable energy, if it's solar or wind, obviously in the nighttime, if you want to operate 24 hours, you need to be able to obviously achieve that. So we're looking at various storage solutions there, whether it's geothermal or whether it's pumped hydro, in order to give us that flexibility so we can maintain that energy energy needs across what we would need to do there. Well, one more? I think there's one gentleman over here.
Hi. Did you guys do any economics between extraction minerals from brine versus traditional extraction ways of those minerals?
Not from a, we've done it from a CO2 perspective. We've looked at basically what our CO2 footprint would be to develop, say, a green magnesium that we would get here versus traditional magnesium, whether it's using like a pigeon process or something like that that you see in China. But no, not from an actual cost perspective per se, in terms of what would be. In many ways, you know, it's a bit difficult to do, because if you look at, say, salt, for instance, salt in Europe, a lot of it's taken from solution mining. The mines are already there. They just basically pump the water down into these mines, and they pull out a fully saturated brine. You know, in our case, we actually separate an awful lot of water before we can get to our fully saturated brine. So perhaps there's a bit more effort there, but it does need to be compared on a like-for-like basis. In other words, the initial CapEx investment of what we're doing versus what perhaps European salt producers did perhaps 20, 30 years ago. Okay, thank you.
Thank you, Greg. Thank you for the good talk. Thank you so
Thank
much.
you.
Thank you, ladies and gentlemen.